In 1946, a 15-year-old boy in Wales looked up at the sky and saw a star that should not have been there. His name was Michael Woodman. He was not a professional astronomer. He was a schoolboy with a habit of memorizing the night sky. And on the night of February the 9th, in a quiet patch of sky called the Northern Crown, he noticed a point of light that had never been there before. He was one of 3 people on Earth who caught it that night. Within days, the star was gone again. But here is the strange part. That same star had been seen before. Not years before, not decades before, 80 years before, almost to the season, and before that, 80 years again. A star that vanishes, waits a human lifetime, and then comes back. The same star, the same patch of sky, the same impossible return. So here is the question that has haunted astronomers for over a century. What kind of star disappears on a schedule? The answer will change how you think about the stars you see tonight, because most of what you call permanent is not permanent at all. It is just slow. Look up at the night sky and you feel like you are looking at something fixed. The stars your grandparents saw are the stars you see. The constellations have not moved in your lifetime. They feel eternal. They feel like the one thing in the universe you can count on. But that feeling is a trick of how short your life is. The sky is not still. It is violent and shifting and full of things that appear and die and return. And one of those things lives in a small, faint, horseshoe-shaped constellation called Corona Borealis, the Northern Crown. Most nights, there is nothing remarkable there. The stars in it are dim. You could look right at it and feel like you were looking at an empty corner of the sky. But hiding in that crown is a star you cannot normally see. Its name is T Coronii Borealis. Astronomers call it TCRB, and the people who love it call it the Blaze Star. It sits about 3,000 light-years from Earth. That means the light you would see from it tonight left that star 3,000 years ago. And here is the first thing you need to understand. The Blaze Star is not one star. It is 2. This is where the story stops being about a star and starts being about a relationship. A deadly one. The first star is a red giant. It is old and bloated and dying. A star like our sun in its final act, swollen to a monstrous size, its outer layers loose and barely held together. The second star is something much smaller and much stranger. It is a white dwarf. A white dwarf is what is left when a star like the sun finishes burning. The core collapses into a ball the size of Earth but with a mass close to the sun. A single spoonful of it would weigh tons. It is the dense, dead heart of a star that already lived and died once. And these 2 stars are locked together. They orbit each other once every 228 days. Close, far closer than any 2 stars should comfortably be. And that closeness is the whole story. Because the white dwarf is doing something to its dying companion. It is feeding on it. The gravity of the white dwarf is so intense that it pulls the loose outer gas off the red giant. A steady stream of hydrogen flows across the gap between them. Astronomers have a word for this kind of system. They call it a vampire star. And the name is not poetry, it is mechanics. The dead star drinks the living one. The stolen hydrogen does not fall straight down. It spirals inward and settles onto the surface of the white dwarf in a thin, growing layer. Year after year, that layer gets deeper, and it gets hotter, and it gets denser, because the gravity crushing down on it is unimaginable. The pressure builds, the temperature climbs, and the gas at the bottom of that layer is being squeezed harder than anything you can picture. This goes on for decades. Quiet, invisible, a slow accumulation that no one on Earth can see, and then it reaches a limit. When the temperature at the base of that hydrogen layer hits roughly 10 million degrees, something snaps. The hydrogen ignites all at once, not a slow burn, a runaway thermonuclear explosion across the entire surface of the white dwarf. It is, in the most literal sense, a hydrogen bomb the size of a planet. And here is the part that matters. The star does not destroy itself. This is what makes it different from a supernova. A supernova is a star tearing itself apart in its final death. This is not that. The white dwarf blows the stolen hydrogen off its surface in a flash of light, brightens by thousands of times, and then survives. The dead star lives to drink again, and the cycle starts over. The feeding, the buildup, the wait. This is why it comes back. This is the schedule. The red giant offers up its gas at a steady rate, so the white dwarf fills up at a steady rate, so it explodes at a steady rate, roughly every 80 years. The same star, blowing the same kind of fuse on a clock set by gravity itself. And now think about what that number means. 80 years. That is one human life. So almost every person who sees the blaze star erupt will only ever see it once. Your grandparents could have seen the 1946 eruption. You might see the next one. Your grandchildren will see the one after that. But no single person watches it twice. It is a star that hands itself down through generations. And here is where the story gets stranger. People have been seeing this star for a lot longer than they realized. In the year 1217, an abbot named Burchard at a monastery in what is now southern Germany looked up and saw something in the northern crown. He wrote it down in Latin. He described a faint star that for a time shone with great light and then faded back to how it was before. He had no idea what he was looking at. He thought it was a sign, a wonder, a message. He was watching a thermonuclear explosion 3,000 light-years away on a dead star feeding off a dying one, and he was watching it 800 years ago. Then it was seen again in 1787, and again in 1866, and again in 1946, each sighting separated by roughly the length of a human life. The same heartbeat, ticking through history, witnessed by people who had no way of knowing they were all looking at the same thing. And this is the part that should stop you. The star you would see flare tonight is the same star a medieval monk mistook for a miracle. The light is the same age. The explosion is the same kind. The only thing that has changed is that now we know what it is. The wonder did not go away when we explained it. The explanation made it bigger. Now you understand the weight, and now you understand the math. 80 years from 1946 lands on 2026. This year, right now. For the last decade, astronomers have watched the blazed star do something familiar. It started behaving exactly the way it behaved in the years before its last eruption. It brightened. Then in 2023, it dipped, a strange, specific dimming, and astronomers checked the records and found that the exact same dip happened in the year before the 1946 explosion. The pattern was lining up. The fuse looked lit, so they made predictions. They named dates. One astronomer ran the orbital numbers and pointed to specific days: March of 2025, November of 2025, and then June 25th, 2026. And here is what actually happened. Nothing. The dates came, the dates went, and the star stayed dark. As of right now, the blazed star has not erupted. Several predictions have already come and gone with no explosion at all. The fuse looks lit and the star refuses to blow. And this is the part nobody talks about. We are not in control of this. We did all the math. We read the history. We matched the patterns. We pointed telescopes and waited on the exact day. And the universe simply did not care about our calendar. The star will go when it goes. It could happen tonight. It could happen a year from now. It could happen the moment you finish reading this sentence, and nobody on Earth can do anything but wait and watch. Think about what that really means. There is a star 3,000 light-years away that has already exploded. The light is already on its way. It left that star 3,000 years ago while empires were rising and falling on Earth, and it has been crossing the dark this entire time. The explosion is not in the future. For the star, it is ancient history. We are just standing at the far end of a 3,000-year-long beam of light, waiting for the front edge of it to arrive. The event already happened. We are only waiting to be told, and when it comes, it will not look like much. There will be no streak across the sky, no sound, no flash you could miss in a blink. A faint star you could not see before will simply be there, as bright as the North Star, sitting quietly in the northern crown as if it had always been there. And then, over a few nights, it will fade, and it will be gone again for another lifetime. So here is what you can do. Go outside on a clear night and find the northern crown. Learn where it sits. Memorize that empty-looking patch of sky, because somewhere in there, right now, a dead star is finishing a meal it started 80 years ago. The light from the last eruption is the same light a monk called a miracle. The wait you are in is the same wait every generation before you sat through. And the next person to look up and gasp at a new star might be someone who hasn't been born yet. You are not looking at a fixed sky. You are looking at a slow one. Everything up there is appearing, dying, and coming back, just too slowly for one life to notice. The blazed star is the rare exception. It moves at the speed of a human lifetime. That is the only reason you get to see it at all. A star that vanishes and returns is not breaking the rules of the sky. It is showing you the rule you were never alive long enough to see.